So in this example, now we're given equations. But the idea stays the same. In A, when I want to do f of g of 9, g of 9 is asking, what is the value of y when I plug in 9 for x? Now with the equations, sometimes you're going to show a little bit more work. So I know that I want to figure out g of 9 first. So I might write g of 9 equals, and then I'm going to plug in 9 into that function. So negative 2 times 9 plus 1 is negative 17. Then I can say that f of g of 9 is equal to f of negative 17. So I did a little bit of work here separately inside the green box here to figure out what g of 9 was first. And then my notation and my trying to write things clearly, I can now say, well, what I originally want to find was f of g of 9. And now that I know that g of 9 is negative 17, I can write that as f of negative 17. Now f of negative 17, that means we're going to plug in negative 17 into f of x. Now with a negative number, especially because things are happening to that negative number, it makes sense to put that in brackets when we enter it. Negative 17 squared. 289 minus 51 238. What do you think is going to be bigger? F of g of 9 or g of f of 9? Well, we'll find out, I guess. So for B, I want to figure out f of 9, because that's what we're going to do first. And that's going to go inside the g function. So 9, squaring that first, it'll be 9 squared plus 3 times 9, 81 plus 27, 108. Now g of f of 9, now we know is g of 108. And if we plug in 108 into our g function, we're going to get negative 2 times 108 plus 1, negative 216 plus 1, negative 215. So the first one is quite a bit bigger because the second one is negative. So again, inside this green box here, I did some work that was separate. I figured out what the inside was first, and then I made sure in my notation that I started off, this is what I wanted to find, and I made it equal to g of 108, and then work through it from there. I would say the number one cause of mistakes with composite functions is notation problems that cause you to do math problems later on. Either trying to do too much at once or trying to mix the notations together. Take it slowly. Take the time. Like, really, there's so many students that won't write this out because they're like, I know that's what I'm doing next. I know that I found 108 and I want to plug that in. Ask yourself, this is like 1, 2, 3, I'm gonna count the brackets as letters. Okay? This is like 1, 2, 3, 4, 5, 6, 7 letters. For some of you, that's less than your name. It does not take a long time to write your name. It does not take a long time to show good notation. In fact, I would argue that showing good notation throughout your math work saves you time. Sure, it takes longer to write things, and when you get the answer right, by writing less, you'll get it faster. But more often, you'll get the answer wrong when you do bad notation. And the amount of time, if you've gotten a wrong answer and you've tried to find your mistake, how long does that take? It usually takes a long time. Because you're like, I don't know where my mistake is. And it also costs you things, because if you decide, I'm not going to even look for it, which happens on tests. How many of you finish your test and actually, with a fine-tooth comb, go through each of your answers afterwards? Okay. Probably not with a comb. But yeah, so if you've written things out neater, you're going to make less mistakes. And then you have less things to worry about. And it will save you time. Okay, questions to do for this one, 6, 8, and 9.